You were expecting Lady Gaga, maybe? Well, you got me. Hi, everyone, and welcome to First Place in Manchester, New Hampshire. This is the Center for First Worldwide, the place where all those wonderful ideas for your robotics competitions are born. So, what better place to unveil this year's First Tech Challenge game? Before we do that, a couple of quick thoughts. First, thanks. Because of you and tens of thousands of folks like you, First Tech Challenge continues to explode. Over 1,500 teams in 2010. That's good news. And yes, you design and build great robots, but because FTC, like all FIRST programs, is a job too big in a time too short with a team too new, you learn a lot more than robotics. You learn about yourself. You connect with others, and you get a much deeper understanding of the technology of tomorrow. That will help you make the world a better place, and that is a big deal. But don't forget, it's not just about you. You're already involved. Congratulations. You know what FIRST is all about, so I'd like to ask you a favor. Get others involved. Parents, mentors, sponsors, teams. Spread the word wherever you go. This is about creating the next generation of technology leaders. We need all of the smart, motivated folks we can get. Are you guys okay?
Sorry, Woody, it's just that there's stuff all over the place here.
Yeah, it's hard not to trip over. What is all this?
This is the First Tech Challenge field and game, and you guys are going to build it.
Wait, us?
Wow, this looks complicated.
It is complicated, but you're first people. Get over it.
This isn't going to be easy, but nothing about an FTC challenge ever is.
Yeah, but that's what makes it so much fun. Come on, let's get started.
Hey FTC, you think you've got it tough? Take a look at the Crusher. A 6.5-ton unmanned ground vehicle designed out of Carnegie Mellon's National Robotics Engineering Center. The main objective in development of the Crusher was to create a tough robot that could go over, under, and through almost any terrain. As a platform, the Crusher can carry a variety of sensors and electronics to communicate with its operators. When FTC developed this year's challenge, they spoke with Carnegie Mellon and others to understand what their challenges were, and then try to incorporate them into the FTC game. One major challenge is how to get robots and their payload over a slew of different types of terrain. Obviously, running around on a smooth set of rubber mats is not what real-world robots deal with. So if you want to be a real-world robotics engineer, you're probably not going to be working just on flat surfaces.
I could use a break.
You hardly did anything.
I got us cold drinks.
It looks like the next step is building something in the middle of the field. This game is going to have some pretty uneven surfaces to deal with.
Now what those guys were saying is starting to make sense.
We don't have much time. Let's keep working.
Yeah, I wonder what else we'll have to deal with.
It's great to see technology used to help understand and solve the problems the world is facing. The sensing and imaging capabilities available today are far superior to what they were just 10 years ago. That opens up all sorts of new applications for the technology. The Sierra Nevada Corporation produces some really cool electronics used for sensing and imaging all kinds of things. During the Gulf oil spill, their products were used to understand the extent of the spill and how effective cleaning methods were at capturing the oil. When we think of imaging and targeting, we may think of military applications, but the use of similar technology is improving our ability to understand and fix global problems, from disasters, such as the oil spill, to improving our ability to identify and treat medical conditions. By the time you're in the workforce, who knows what you'll face? But you can be sure that the technology you're using now will improve and be used to solve tomorrow's big issues.
Well, that explains these.
I actually think you're paying attention. And looks like this goes here. And here.
I'll take care of that one. Hey, this is new.
More new technology. I'll bet that's the new communications module. What's that thing called again?
That's the Samantha module.
John Tobis from Cisco. What brings you to town?
Well, I wanted a chance to get a sneak peek at the new FTC field. And of course, to talk a little bit about what's going on with the new Wi-Fi module.
So, I gotta ask, why is it called Samantha?
Oh, that's easy. The guy who did the hardware design, as a reward, we let him name it after his daughter.
Aw.
Well, could you please tell us how it works?
Sure, it's magic. No. So the reason why we developed the Wi-Fi module was in order to get better reliability for the teams. Okay. You see, Wi-Fi has a number of advantages over Bluetooth, and in the FTC competition field, it allows us to bring the robots on and off the field much more quickly. The way it works is, we combined a USB interface with a wireless interface, so that as far as the NXT is concerned, it's just talking to a computer. Yeah. So it means no change to your code.
So, faster, more reliable connections. That's the main benefit?
Well, the fact that it's Wi-Fi means we can talk to it from a number of different places, include not just your PC, but also an iPhone or an iPod Touch.
Could that be used in competition as well?
No, you can't use your iPhone in competition, because what's going to happen at the competition field is we will have a central computer with all of the joysticks available for you. So all you got to do when you come onto the field is just carry your robot.
So, you did all this yourself?
No. There's over 2,500 hours of development on the Samantha module. Couldn't have done it without the help of my wife, Mary Ellen, Dave Baker and Mark Schnell from Cisco, James Ram from First, and Tom Saxon, who did the iPhone app. And of course, we have to thank the Kauffman Foundation. They graciously donated the money so that this year every team will get a Samantha module for free.
Well, all we can say to that is thank you.
Oh, you're welcome. Good luck. And good luck to you, too.
Nice job on those IR beacons.
Thanks. It was easy because they were used last season. They were part of the center goal assembly on Hotshot.
Oh yeah. If you were on a team last year, then you'll have a head start programming your robots to use those.
And if you're new this year, this is one of the things you'll have fun learning.
All right, so we have the field border, the floor, the center assembly, and the IR beacons are wired. What are all these tubes for?
My guess? Scoring.
Last year we used balls.
And the year before that, street hockey pucks. Oh, and rings before that, right?
Right, excellent memory.
We're gonna need another clue to figure this out.
Robots come in all shapes and sizes based on their purpose. The PackBot from iRobot isn't too much bigger than your FTC bots. The PackBot was designed for a range of applications, including first responders who need to deal with dangerous situations. Robots are ideal in these situations, and the best have the ability to manipulate odd-sized objects like tubes. Not only can they manipulate objects, they can be designed to identify what's inside them using sensors and the correct programming. If you look closely, you'll catch a glimpse of a controller that looks very similar to an FTC robot gamepad. The future is already here, and these types of robots are keeping our first responders safe using some really cool technologies. The FTC Game Design Committee built some pretty interesting stuff into the game this year. Things that should make this last video segment make sense in just a few more minutes. Good luck, FTC.
Okay, so these are what the teams will use to score with, but why are they all different colors?
Must be to help field reset.
But I did notice something hidden inside 4 of them. So what we just saw makes sense.
Boy, there sure is a lot going on here. I counted 100 scoring elements.
And what is this?
Remember what Woody said?
Get over it.
Each team has 1 robot and 3 human players, 2 driver operators and a coach, who can be a student or an adult mentor. The robot must be constructed from materials specified in the FTC manual, so it obviously won't look like these. All robots must fit within an 18-inch sizing cube at the start of the match, but can expand to any size during match play. 2 teams make up an alliance. Your ally in one match might be your opponent in another. The scoring element is a baton, cut from half-inch PVC pipe. 100 batons are used in the game. They are stored in 6 dispensers arranged around the field. Each alliance is also given 5 batons that can be preloaded onto their robots. In addition, there are 2 doubler batons and 4 magnet batons, which look just like regular batons and are randomly loaded in the dispensers. The game is played on a 12-foot square field covered with interlocking foam tiles. On opposite sides of the field are the red and blue alliance stations. And on field, there are 4 taped-off starting areas for the robots. There are 3 red and 3 blue baton dispensers mounted around the field in high, medium, and low positions, each loaded with 15 batons. The medium height dispensers have an infrared beacon mounted near the bottom. Each alliance has a corrugated plastic stationary goal with a cliff leading up to it. There are 4 rolling goals, 2 red and 2 blue, and a mountain is located at the center of the field. On either side of the mountain are 2 bridges that can pivot up and down, but have a naturally level balance point. A 40-second autonomous period starts the match. Human control is not permitted. Batons scored will count twice, once at the end of autonomous period and again at the end of the match. Immediately after the autonomous period is a 2-minute driver-controlled period. The last 30 seconds of this period is the end game. You may not contact your opponent's bridge during the end game. If your robot is parked on a cliff at the end of the autonomous period, it counts 3 points. Parking a robot on the mountain or an unbalanced bridge is worth 5 points, and parking on a balanced bridge is worth 15 points. Having a robot on the dispensing side of the field counts 10 points. Dispensing batons from your alliance's dispenser counts 2 points each. A regular or magnet baton scored in the stationary goal is worth 1 point. A regular or magnet baton scored in a rolling goal large cylinder is worth 3 points. A regular baton scored in the 2-inch cylinder isn't worth anything. However, a magnet baton scored in the 2-inch cylinder counts 25 points. And the doubler baton will double the score for all batons in a goal. At the end of a match, a robot or rolling goal balanced on a bridge counts 10 points. 2 elements, robots or rolling goals, balanced are worth 20 points. 3 elements are worth 30 points. And if you have both robots and both rolling goals balanced, it counts 40 points. We want you to always keep gracious professionalism in mind. Violating certain rules will result in score reduction or even disqualification. For example, pinning another robot, or intentionally descoring batons or tipping over an opponent's rolling goal. Thoroughly study the game manual and field drawings for complete details. Good luck, teams!
Now it all makes sense. This is going to be so cool.
Really hard, but really fun.
Okay, FTC, are you ready for this?
Now that you've seen the game, let's get started so we all can figure out how to
Get over it! See you on the playing fields.